So this is the review slash practice test for exam 1 for Chem 1410. It's the one where Julie Fuller is the instructor, but this is probably an excellent review no matter who your instructor is. And so I'm going to go through these just one section at a time, have one video for each section. We're starting with classifying different things as either an element, a compound, a homogeneous mixture, or a heterogeneous mixture. And for all of these, it's good to have a periodic table handy. If you have one printed out that you're looking at during your test, that works. I really like this particular online one if you're going to use an online one because it has lots of information in it and it's kind of interactive. And it's just ptable.com. Okay, so the first one it's asking about salt. And so for this one, you would need to know that salt is sodium chloride. And so because it's sodium chloride, it is made up of sodium and chlorine, and they are chemically bonded together. It's not just a mixture of sodium and chlorine. There are chemical bonds holding them together, and that makes it a compound. You can recognize that by how the name is put together. If they call it sodium chloride, then it's a compound. If they refer to it as sodium and chloride, then you know it's a mixture. Phosphorus is something that you can find its own square of on the periodic table. It's right here, atomic number 15, phosphorus. And if we go to properties, it just enlarges it for you so you can see this is the chemical symbol and that it's phosphorus. It's also possible with this one to turn on the search. If you aren't sure if it's there and you're looking and the words all written out, they're pretty small. So you can just type in phosphorus, and if it shows up, then it's a single element. If it does not show up, then it's not an element. So just and make sure you're spelling it correctly. So back to the question. So that makes phosphorus an element. An element is anything that has its own square on the periodic table. Sulfur dioxide. Notice it doesn't say sulfur and oxide. So that makes it a compound made out of sulfur and oxygen. The names of compounds are always going to be made up of names of elements, other than a few exceptions, things like water. That water is its common name, but for the most part here, what you're looking for something to be a compound is it is made up of 2 or more elements, and those are usually easy to identify from the name. So in this case, it's a compound made up of sulfur, which is right here, and oxygen. The dioxide refers to it having 2 oxygens in it. So sulfur dioxide is a compound because it's made out of more than one element, in this case sulfur and oxygen. Iron ore, this is another one where you'd have to know something about it, but this is going to be true of all ores. Ores are what is usually mined out of the ground, and then the metal is extracted from the ore. So iron is an element, but iron ore is iron mixed with a whole bunch of other stuff, and it's not a chemical compound. It's not iron. Iron oxide, for example, would be a compound, but iron ore is iron mixed with other things, not chemically bonded to other things. So that makes it a mixture, And then you need to know if it's a homogeneous or a heterogeneous mixture. So again, that requires you to know something about ores in general. And as far as I can tell, all ores are heterogeneous mixtures. And here's an example. I just did a Google Images search on iron ore. And in this image, you can see the different parts that go into it. If it was homogeneous, it would be all one color. But since you can see the different parts of it that are different colors, that's one thing that makes it identifiable as being heterogeneous, different in different places. And then here's another image where you can kind of see the non-uniform colors in it, and that is another indication that it is heterogeneous, not the same everywhere. Gold, if we're unsure whether gold is an element or not, we can do the search like we did before. Just type in gold, and sure enough, it shows up. It's its own element, and that, of course, makes it an element. Those are the easiest ones to verify, to know for sure what it is, because it's going to be the actual name of the element. Clean air. So oftentimes we think of air and oxygen as the same thing, because oxygen is the component of air that we're the most interested in, that we have the most knowledge of. We know that we need oxygen to breathe, to live. But air is actually a mixture of a bunch of things. Most of them are elements. Here is a pie chart of what air is made out of. So it's mostly nitrogen, which is inert, so it's just there, but it's not really participating in anything. Pure oxygen, though, is flammable, so it's a good thing air is not all oxygen. So we've got mostly nitrogen, good amount of oxygen, some argon, and then all these other things: xenon, neon, hydrogen, helium, krypton, and carbon dioxide. You do not, as far as I know, need to know that list. If anything, knowing that it has nitrogen and oxygen in it might be a good idea. Probably not something you specifically need to know either. But all of these things, with the exception of carbon dioxide, are elements. And carbon dioxide is a compound made of carbon and oxygen. But whether it's a mixture of different elements or a mixture of different compounds, it's still a mixture. That doesn't change its category at all. And the reason we know that this is a mixture and not a compound is that each of these components of it maintains its own identity. Nitrogen is not chemically bonded to the oxygen or to the argon or to the xenon. If all of these things were chemically bonded to each other, then it would be some kind of giant compound, but it's not. It's just a mixture of all these different gases. So we know then that it is a mixture, and as to whether it's a homogeneous or a heterogeneous mixture, that we know because it's a uniform composition. It's not like all the oxygen goes to one side of the room and all the nitrogen goes to another. It's uniform mixture of all of the different elements in it. And that makes it homogeneous. And that's it for these classifications of element, compound, homogeneous mixture, and heterogeneous mixture.